We're on Chapter 5, Section 1, which is Learning Plan 3.1. We're going to do integer exponents and scientific notation. By the integer exponents, then we're going to be having the product rule, zero and negative exponents, quotient and power rules. We're going to simplify those and then do scientific notation. So 2 to the fifth is how we read this, is defined as 2 times 2 times 2 times 2 times 2, or 32. 5 is the exponent. The 2 is the base. We either call it an exponential or a power function. So this is either 2 to the fifth power or just simply 2 to the fifth. What does the product rule says? The product rule says that if you multiply two numbers, you can add their exponents. Make sure that you only do it when the bases are the same. So this would be m to the 8 plus 6, which is m to the 14th. This you can't simplify because the bases aren't the same. You multiply these numbers and you get 45, but then you add the exponents p to the 9th. Multiply the numbers, negative 21. X will be to the 2 plus 1, which is third. Y will be to the 3 plus 4, which is 7. Notice if there's no exponent there, assume the exponent is 1. Now you do these. Okay, so the first one is 8 to the 5 plus 4, which is 9. Second one, multiply the numbers, negative 35. X will be to the 5th, 4 and 1. Y will be to the 10th, 3 and 7. This one we can't simplify because the bases aren't the same. You do this one. Multiply the numbers, will be positive 12. X will be to the 14th, that's 5 and 9. Y will be to the 3rd because of 2 plus 1 is 3. Now, if you have a 0 and a negative exponent, what happens? Well, any number to the 0th power is 1, except 0. You can't have 0 to the 0th power. So this will be 1, 29 to the 0th. Negative 29 to the 0th is still 1. This is negative 1. Think about it this way. X minus 29 to the 0th is x minus 1. So this negative sign doesn't go into that number. This is 1 minus 1, which is 0. You do this one. A is 5 to the 0th, which is 1. Any number to the 0th is 1, so negative 5x to the 0th is still 1. Negative of 5 to the 0th, well, 5 to the 0th is 1. Negative of that is negative 1. And then 10 to the 0th is 1. Minus 9 to the 0th is 1. 1 minus 1 is 0. How about these two? Negative 2 to the 0th is 1. Negative 8 to the 0th is 1. 1 and 1 is 2. So that's the correct answer. The opposite or negative of 6 to the 0th, 6 to the 0th is 1. With a negative out front makes it negative 1. How about negative exponents? Well, a negative exponents means to switch numerator and denominator or take the reciprocal of the number. Notice, 3 to the negative second is 1 over 3 to the negative second. The opposite of 3 to the second is negative 1/9. So notice the difference between those two. This is 1 over 6 to the 5th. This is 1 over 2x to the 4th. 2 to the 4th is 16, x to the 4th on the bottom. Negative 7 stays on top. P is to the 4th. Notice they didn't do the whole thing, p to the 4th, just the p was to the negative 4th. 1 over 4 minus 1 over 2, 1/4 minus 1/2 is negative 1/4. How about these four? This is 1 over 9 to the 4th. This is 1 over 3y to the 6th, which is 3 to the 6th, y to the 6th. This is negative 4 over k to the 3rd. And then last one, this is 1/4 plus 1/6. Make them both 12ths. That's 3 12ths plus 2 12ths is 5 12ths. Next one. Notice the whole thing is to the negative third. So it's 4 to the third, p to the third. 4 to the third is 64. So it's 1 over 64 p to the third. You know, it depends on when you would multiply that out and when you wouldn't. I'm not multiplying out 3 to the 6th because that's a big number. I'm not sure what it is. 216 maybe? No, it's probably even bigger than that. It's a big number. How about this one? Now we've got the negative on the bottom. So that is the reciprocal of the reciprocal, which makes the 4 to the third on top. 4 to the third is 64. The 3 to the negative third, so the 3 goes on the bottom to the third. 9 is to the negative first, so the 9 goes on the top. 3 to the third is 27. 9 over 27 is 1/3. How about these two? So this would be 5 to the third on top, which is 125. 10 to the second goes on the bottom. 2 to the negative fifth goes on the top as 2 to the fifth. 2 to the fifth is 32 over 100, which I suppose you could write as 16 over 50. Oops, or 8 over 25. How about this one? 5 to the third goes on the bottom is 125. 4 to the fourth goes on the top is 256. So the correct answer is C, 256 over 125. So if you have both numbers as reciprocals, you can write them in the opposite spot. How about the quotient rule? Well, the quotient rule says you can subtract exponents when you divide. Be careful when working with quotients that involve negative exponents in the denominator. Write the numerator exponent, then the subtraction symbol, and then the denominator exponent. So this is m to the 8 minus 13, which is m to the negative 5. And since we want it as a positive exponent, we would write it as 1 over m to the 5th. This is 5 to the negative third minus negative 8, which is 5 to the negative 6th plus 8, which is 5 to the second, which is 25. Last one. You can't simplify this because they don't have the same bases. Okay. T to the 8 minus 2, which is t to the 6th. 4 to the 5 minus negative 2 is 4 to the 5 plus 2 is 4 to the 7th. Last one you can't simplify because the bases aren't the same. How about this one? X to the 6 minus 15, which is x to the negative 9, which is 1 over x to the 9. Notice this is not, that right there is not this. The negative sign is in a different spot. That's negative of x to the 9th. How about use the power ruling for exponents? So in other words, when you take a number to a power, you multiply the exponents. So this would be r to the 5 times 4, which is r to the 20th. Negative of negative 3 to the second is 9. Y to the 5 times 2 is 9y to the 10th. 3 to the third over 4 to the third is 27 over 64, which you can't simplify. How about these two? Well, negative 2 to the 4th is 16. M to the 3 times 4 is 16 m to the 12th. 3 to the 3rd is 27. X to the 6th over y to the 9th. This one, you're going to square this. So negative 3 squared is 9. W will be to the 10th. x will be to the second. So 9w to the 10th over x squared. Now, if you have a negative sign, remember you're going to switch numerators and denominators around. So this is 3 over 2 to the 4th, which is 3 to the 4th over 2 to the 4th. 3 to the 4th is 81, 2 to the 4th is 16. This is 2x to the 5th, which is 2 to the 5th is 32, x to the 5th. How about this one? That's 3 goes on top, 5 goes on the bottom to the 3rd. 3 to the 3rd is 27, 5 to the 3rd is 125. And this one, the negative sign makes it 3, positive 3 to the 4th, which is 81. So those are our rules: the product rule, the quotient rule, the zero product rule, the negative exponent rule, the power rules, and then those special rules. Let's do some simplifying, okay? We have, I have to look at this one because there's a mistake, I think, in that second one. Yeah, this is supposed to be a times sign here and here. So this is 4 to the negative 10th, which would be 1 over 4 to the 10th. This is negative 6 minus 6 more is negative 10, plus 8 is negative 2, which is 1 over x squared. The negative sign tells us to put them in the denominator, so we've got m to the 2 times 2, n to the 2, m to the negative 3, which means it's going to go up on top as m to the 3rd, n is on the bottom. So we have n to the 3rd on the bottom. 3 minus 4 is negative 1, which would be 1 on the bottom. How about these 3, or 4? First one, negative 8, plus 1 is negative 7, plus 4 is negative 3, which would be 1 over x to the 3rd. 5 to the negative 3rd to the second is 5 to the negative 6th, which is 1 over 5 to the 6th. I'm going to change color so that you can see the next one. P to the second over q to the 4th, that's the numerator. P to the second, that's the denominator, and q to the 1st, and the numerator is the other one. So this would be p to the 4th. 1 minus 4 is negative 3, which would be, q to the 3rd. Last one, 2 cubed is 8. X to the 6th over y to the 6th. Switch the numerator and denominator makes y to the 2nd on top. Negative 5 to the 2nd is positive 25. X to the negative 2 on the bottom is the same as x squared on the top. So we have x to the 8th. I suppose we should put our numbers in. 8 over 25. X to the 8th. Y to the 2nd. Minus 6 is y to the negative 4th, which is the same as y to the positive 4th in the denominator. This one, we have 1 over 3 to the 2nd, which is 3 to the 4th. 4 to the 5th to the 2nd is 4 to the 10th. So it's 1 over 3 to the 4th times 4 to the 10th. This one, 2 to the 2nd is 4. Y to the 2nd over x to the 2 times 3 is 6. Switch numerators and denominators. So the 4's cancel. This y cancels against one of those y's. 2 minus 1 is 1. X minus 6 is negative 5, which is x to the 5th on the bottom. Scientific notation. In scientific notation, a number is written with a decimal point after the first non-zero digit and multiplied by a power of 10. So it's a good way to express very small or very large numbers. The first number is between 1 and 10, and then the power tells us what we write it to. So we place the decimal point in the correct spot, and then count the number of decimal places that we move. Put the decimal point after the first non-digit number, and we move the decimal point 1, 2, 3, 4, 5, 6, 7. So it's 2.98 times 10 to the 7th. Okay, this one, 5.03, but we're going to go backwards. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the negative 8. If it gets closer to 0, between 1 and 0, then it's going to be to a negative number. Okay, so this would be 7.56 times 10 to the 3/6/9. Negative, this negative sign is needed. 2.45, put the decimal point here. 1, 2, 3, 4, 5, 6, 10 to the negative 7th. How about these two? 8.11 times 10 to the 1/2. And then 6.07, 1, 2, 3, 4 times 10 to the negative 4th. Okay, and then when you go from scientific notation, you write the digits 2, 5, 1, move it 3 places, 2, 5, 1, 0. Negative, and since it's going backwards, 1, 2, 3, 4, 1, 2, 3, 6, 8. How about this one? 4, 4, 5. That's only moved 2 places. 3, 4, 5, 6, 7, 8, 9, 10. Count off your groups of 3. So it's 44,500,000,000. Negative sign, that's that. And we're going to move the decimal point 5 places, which means we're going to have 4 zeros, a 5, and a 9. This one, 0, 0, 0, 3 zeros, a 5, 7, 1. So it'd be the second one, B. Using a scientific notation for computation purposes, I would use my calculator for that, and I would write 200,000 times 0.0003 divided by 0.06, and I would get 1,000. Instead of using scientific notation, working with scientific notation is easy with a calculator, but otherwise there's no point to it to switch to scientific notation to solve your answer. So for this one, 0.00063 times 400,000 divided by, make sure you use parentheses on the bottom, 1,400 times 0.000003, close parentheses, and I get 60,000. How about this one? I get 0.45 C. The distance the sun travels is 93 million miles. How long would it take a rocket traveling at 3.2 times 10 to the third miles per hour to reach the sun? Distance divided by rate is time. So we would take 9.3, and then there's, on my calculators, there's an EE key, 7. So my calculator just says 9.3 E7 divided by 3.2 E3, and I get time is 29062.5, which would be 29,000 hours. If you take 29,000 hours divided by 24, you get how many days it is, which is 1,210 days. Divided by 365, you would get 3.3 years. That's a long time. How about this one? So we would take 30, 000, 000, 000, 000, 000, distance. Oh, we have to take the time, the distance divided by time. 1.2 exponential 15 divided by 3 EE 10, and we get 40,000 seconds, which I'm going to divide by 3600, which is 11 hours. Almost half a day. How about this one? So we'd type 6.68 times 10 to the 9th divided by 2.974 times 10 to the 6th. Each person would owe $2,246. Nope, not $100, $1,000.